If you like titles, the title is there, Empirical Molecular Formulas. We're going to start off with definitions because they are similar yet have some key differences. So I'll give you a moment to write down the definitions. Then we're going to jump to examples so you can see how we determine these and what similarities and differences there are between them. They are connected, but they are different ideas. So knowing how to convert from one to the other is the goal of today. Nope, that's not what I meant to do. Whoa, come on. My apologies, everyone. There it goes. All right. Looks like we're close to being done. I'll wait a little longer. The empirical formula is the lowest whole number ratio of the elements. So it's a formula for the compound where if it can be reduced, it has been reduced. It's the lowest whole number ratio. That might make it the real life formula, that might not. That's why we also have molecular formula. Molecular formula is the real life formula for that compound. Even if we can reduce, we don't with the molecular formula. The molecular formula is unreduced, unsimplified. The empirical formula is reduced, is simplified. The molecular formula has to be some whole number multiple of the empirical formula. So if I reduced a molecular formula by 2 to get it to an empirical formula, then I know I take my empirical formula, multiply it by 2 to get back to the molecular formula. So they are connected. Knowing enough information for one tells us the other. We're going to connect them in 2 ways. We're going to take the molecular formula and then reduce it to find the empirical formula. So our first examples are going to be that way. And then we're going to take the empirical formulas and figure out what to multiply it by to get it to be the molecular formula. So the 2 examples after that are that way. So you need to be able to convert from one to the other with the information I provide. And that's why we're going to actually have 2 practices in Canvas. You're going to have a practice going from molecular to empirical and one going from empirical to molecular. So we're going to do examples of each kind. This first type is very different than anything we've done this year. I don't think that makes it difficult. What might make it difficult, like if you're like me, is that you have to count stuff. And if you lose track as you count, especially on a computer screen, it could go bad. So when you're counting, you want to go slow and careful. Maybe even write it down on your paper, even though it's on the computer screen and you're trying to count it. Maybe write it down so you can like scratch it out as you count it or something. Just a suggestion. But here's an example of how we would take a molecular formula and then turn it to an empirical formula. So for this example, you will need to draw that picture in your notes for this to make sense. I tried to start us with a nice, easy picture to draw. So I'm going to give you a moment to draw the picture, and then you can see those blanks there. We're going to find the molecular formula, and then we're going to find the empirical formula. So the first practice in Canvas is going to be this way. I will give you a picture. And by the way, this is the way you're going to see this kind of question on the test. I'll give you a picture. And I'm going to ask you what the molecular formula is. And then from the molecular formula, we're going to find the empirical formula. So first off, I want to list the elements in alphabetical order. That's the way we do that. So my first elements that I'm going to list is going to be carbon. My second element I'm going to list is going to be hydrogen. And then my third is going to be oxygen. If I had any other elements, I would list them in there. We're going to go in alphabetical order. It's what we do to write formulas for these things. So tell me, how many carbons are in that picture? 2. So after the carbon here, I'm going to put a little subscript 2 to tell 2 carbons. How many hydrogens are in that picture? Yeah, I know. I do the same thing. I start counting and I'm not sure, did I count this one or not? You might want to count it 2 or 3 times just to double, triple check. How many oxygens are in that picture? Okay, so there's my molecular form. That's all we do for the real life molecular formula. We write down what we see. You do have to count them well, so it might be a challenge sometimes. So go slow, be thorough, make sure you count it well. Now we want the empirical formula, and I have the molecular formula. So I need to reduce that molecular formula. Can I reduce that molecular formula? I can. What do I divide all those numbers by? 2. So what does that leave me? That leaves me a C, because we don't write a 1. That leaves me an H with a 2. And that leaves me a O, because I don't write the 1. There we go. There's our empirical formula. So you'd be typing into boxes in Canvas, you'd be typing in C2H4O2 as the molecular formula. Canvas won't let you do the little numbers, so just use regular numbers. Exactly. If I can't reduce it, the formulas would be exactly the same for both. And that can happen. It is a possibility. And then here I could reduce. So in the second blank in Canvas, I would type that in. Again, I type in C, H, a 2, and an O. Canvas won't let students type in little subscripts, so just use a normal 2, and that's all you need to type in. We okay so far? All right, let's try another one. Same thing, you'll want the picture in your notes, and then we're going to find the molecular and empirical formula. I'll give you a bit of time to draw this. It's got a lot of everything, yeah. I had a student a few years ago who would put these in her notes and then highlight in different colors the different elements to count them well. That's fine. I don't expect you to do that, but it'd be a great way not to lose track of any numbers. As we do this together, I'm going to be crossing out the elements as I count them in a hope of not getting a wrong count. By the way, I'm sure you all wanted to know how to make TNT, right? There you go. That's TNT right there for you. Yeah. Trinitrotoluene. What's brown and sticky? A stick. See, notice how he pretends to get it, even though he really doesn't. Nope, I didn't even notice. Now, again, as you're practicing in Canvas, the picture is going to be on the screen. You don't have to draw it in your notes, but if you do draw it down, even on scratch paper, you could do like I'm going to be able to do and cross out the things as I count them. Might be helpful if you want to make sure certain your counts are good. What I did as I was building the questions is I 3 times through counted everything just to make certain I was counting it well. So if you don't write it down to cross it out, you might want to be sure you count it 2 or 3 times just to be certain. Okay, it looks like most people have it about drawn. There's a lot of like double bonds in there, single bonds. None of that's going to matter to our work. We just care about what elements are in there. Of all those elements in there, which one comes first in the alphabet? C. So let's start with our C. So let's start counting C. So I'm going to count at the top just to have a place to start. So 1, 2, 3, 4, 5. Wow, my crosses aren't working well. 6, 7. Are there any more C's I didn't cross out? Okay, thank you. So we'll call that C7. Okay. What's next in the alphabet then? Let's go H, exactly. So H. So start counting as I let this person in. And okay, I heard a 5. Let's see. Where'd my pen go? There it is. 1, 2, 3. Okay, and then yeah, down below here we got 4 And over here we got 5. Okay, any other H's? Nope, 5 looks good. Thank you, Ellen. And what's next? N or O? Yeah, this might be the hardest part of it, like remembering your alphabet, right? Or maybe it's just me. Maybe I'm the only one who has a hard time. I think I see 3. Is that what I'm seeing? Okay, so 3 N's. And now the O's. 1, 2, down below 3, 4, over on the left 5, 6. Are you getting 6 as well? Okay. So there's our molecular formula for TNT, trinitrotoluene. Here's the big question, which Alan beat us to last time. Can I reduce any of those numbers? Well, the 6 and the 3, but would I be able to do the same with the 5 and the 7? No. I can't divide them all by something. It's not going to work. So what does that mean? That means your empirical formula is the exact same as your molecular formula. So you're going to type it into Canvas twice in this event. Sometimes they're the same, sometimes they're not. The only way to know is just to do it and ask yourself. No, in fact, I'm not wanting you to put commas or spaces. I literally want you to type in C and capital C and 7, capital H5, capital N3, capital O6. And I do list that out in the questions. I'm like, be certain you do this, 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 and this. Because unfortunately, these kind of questions in Canvas are matching. If you put in a space, even accidentally, it's probably going to count it wrong. Now, in that event, you let me know, I go back and I'm like, yeah, you typed in the right thing, just accidentally put a space, and I can give you the points back for it, okay? But just know it's very particular. You got to match what I put in, otherwise it won't work. And this is how I put it in. I would put in C7, H5, N3, O6, no spaces. All those letters are capital. That's what we put in. So this is going to be the first quiz we take today. It's going to work this way, turning molecular formulas into empirical formulas. The other way that we're going to do it today is to turn empirical formulas into molecular formulas. Very different process. So let's give this a try with 2 examples. And I'm going to set up in Canvas to have these 3 parts to each one to guide you along the way. So here's important information number 1. We have the empirical formula given to us. I have to give you that for you to do this. First thing we need to do is figure out the molar mass of that empirical formula. Now, we've done this since the beginning of our unit. We'll be doing this all year long. What do I add up to get the molar mass of CH? Yeah, C plus H, thank you. So I go to the periodic table. Here's mine. I find the mass of C. 1C is 12.011. And I see H is 1.008. Oh, I forgot the labels, grams per mole on each. Now, sadly, Canvas won't let me ask you for labels, so you'll put in just the number. But all I'm going to do for the molar mass is just add up what the empirical formula has there. So 12.011 plus 1.008. Hopefully I typed it in correctly. I'm going to round to the hundredths place. It'll tell you where to round in Canvas. You can ask me what that means when you get there. If you're not sure what decimal place to use, that's okay. I don't mind answering that. Even on the test, I wouldn't mind answering that. 12.11 grams per mole. And now look at important piece of information number 2. I also have to give you this. The molecular formula, the big one, the unreduced one, has a mass of 78.11 grams per mole. We need to figure out how many times more that is. So check out what I'm going to do. I'm going to take the big number they gave me. I'm going to divide by the molar mass I found. And if someone would do me a favor and type that in a calculator and tell us what we get, it is division. $78.11 divided by 12.11. 6.45. That's what I heard. Anyone get that same number? Yeah. You know what? That's not the right number, and I know why. Because no one checked my work on the first one. Shame on you all. 12.011 plus 1.008 is not 12.11. 12.011 plus 1.008, 13. Let's try this again. 13.02. Wake up, you need to catch my mistakes so I don't lead everyone astray. I need your help here. Okay, now let me ask you to do that again. 78.11 divided by 13.02. Okay, I heard a 5.999999999. You get the idea. Can I get someone else to double that, to like second that? Double check it. Is that what we get? Same thing? Okay. Well, we got it triple checked. All right, that's good news. Because what I want here is a whole number. What can I call that number that's a whole number? 5.999999. What can I call that? 6, exactly. Let's round that to 6. You may not be at a whole number when you do this part. You better be extremely close where you can see it. It's going to round to a whole number. That's how I knew I must have done something wrong, because 6.49 wasn't even close to a whole number. So I'm promising you these work out to where you get like a whole number going on here, 6. What does that 6 tell us? The molecular formula is 6 times bigger. So here we go. Let's take the empirical formula and make it 6 times bigger. It was CH, so what's it going to be now? 6 times bigger. 6 C's and 6 H's. Yeah, it was 1 C1H, multiplying both by 6. Now it's C6H6. So that's what you type into the box in Canvas for your molecular formula. So these Canvas questions are going to guide you along the way. You're going to want a whole number for the times greater. If it doesn't come out very, 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 very close to a whole number, let me know so I can double check. Again, it could be I put the wrong numbers in. I've double checked my bank, but who knows? I could still make mistakes. As you just saw, I'm very prone to making mistakes. So you type in capital C6, capital H6, enter that into Canvas. So that's one example. Let's do one more, and then we'll get into Canvas, and you have plenty of time to work through this, have me help you, let me know that I made mistakes, whatever the case may be. I have to give you the empirical formula. So I have HNO2. And speaking of mistakes, I wrote the wrong word down there. Okay, first thing we need to do is find the empirical formula. So I'm going to add how many H's? 1H to how many N's? 1N, so 14.008, I think, 7. 14.007. And how many O's? 2. You could totally go 15.999 plus 15.999, do it twice. You could do 15.999 times 2. Your calculator will handle it either way. If I could get someone, because I'm no longer trusting myself, if I could get someone to tell me what we get there, I'm guessing it's around a 48-ish number. Okay, 47.013. That sounds close. Can I get someone else to let me know they got that? Yes, okay. We're going to go with that. That would be grams per mole label. Unfortunately, Canvas doesn't. Come on, tablet. Canvas doesn't let us put in labels, but that's what that would be. Piece of important information number 2, I have to give you the actual mass of the molecular formula. So I'm going to take that actual mass of the molecular formula in grams per mole and divide it by the one we just found in grams per mole. I'm going to pause and let you catch up before I ask this next question. When I take 47.01 and divide by 47.013, what number am I pretty much getting? Right, not subtracting. You're right, you were subtracting. When I divide, I get 1. What does that tell me? It is 1 mole of everything. It did not change. It turns out the empirical formula was the molecular formula, and that can happen. They could be the same. They don't have to be. That's why we do these steps to find out. There's no way to know ahead of time, but that is what we do. Okay, so there's 2 practices in Canvas. The first practice is like those first 2 questions where you will have a picture. You're going to very carefully count it up and then simplify it and enter both into the blanks. And then the second bank is just like this, where I'm going to ask you the questions one at a time with I will give you the information you need, and that will lead you to the final answer of what your molecular formula is. Both should be done here and now. I'm betting both can be finished before you go, and please listen well. This is the last topic of our unit. When I see you again Tuesday, because Tuesday's our next odd day, when I see you again on Tuesday, we're going to review, and then our test is going to be Thursday. So it's also a great day, and especially over your long weekend, to go to Canvas, make sure you have a grade for every assignment that starts with the letters U and 10. Every assignment of U10 in Canvas should have a grade for it by the end of today. So make certain you're working towards that so you can be caught up and good to go for the test. Okay, so again, in Canvas, when you click the page for today, there's 2 practices. And I am begging you, please let me know if you enter stuff, submit it, and you don't know why the answer isn't what you put in, because it could be I messed up on typing it in the first place. And I need to know that in order to fix it. So give them a try, submit it, keep trying them till you make hundreds. But if you look at an answer and it says it's wrong and you don't know why it's wrong, please involve me. It could be I messed it up and I can't fix it if you don't let me know. Online students, I am going to mute myself, but I will be listening the entire time. So just like those students in class, please ask for help when you want it, especially if you get an answer wrong and you're not sure why. It'd be a great time to let me know so I can double check I even put it in correctly. Yes. Yes.